In this video series, we are talking about a mixed design, and we're using the one between and one within subjects factor design as an example. The units in different levels of the between subjects factor are independent of each other. That's what makes it a between subjects factor. The units in the different levels of the within subjects factor are correlated because those units are measured at each level of that within subjects factor. All levels of the within subjects factor are in each level of the between subjects factor. The primary interest in this design is the interaction of the between subjects and within subjects factor. Let's take a look at why that is. Using our example, I'm going to analyze the row gain data that I introduced in the previous video. Here's a box plot to look at the results of our data or of our study. And in this box plot, what we have here is yellow is the control or placebo condition. Green is the treatment or row gain condition. And we're looking over time. We have weeks 0, 8, 16, 24, and 32. And remember that the response measure is the average daily weight in milligrams per square centimeter. That is the weight of the hair that was cut off that little space that was equal for each of the women. Now, one of the first things that I notice when I look at this box plot is that we have less variability in each of these yellow boxes than we do in those green boxes. What that tells me is that it seems like the row gain treatment may have influenced the women differently. Although I note that even before the study started at time 0, that we seem to have wider variation in the women. Why is that? Well, that is just a function of the particular sample that we obtained. Also notice that the box plots could be a little bit misleading here because behind the scenes, what is within each box plot? 4 women, just 4 measures. So this box plot in which we're looking at minimums, quartiles, medians, so forth, are all based on just the 4 women's scores. But I do see that there's more variability in the row gain group than there is in the control or placebo group. But looking at time 0 leads me to believe that, you know what, the variability actually was pretty high to begin with. And so when I see time 16, for instance, with a whole lot of variability because of the row gain treating women a little bit differently, it's not as pronounced as one might suspect because of the wide variability before we ever began. So this box plot is a first clue as to the primary thing we're looking for, and that is to see whether the growth pattern in row gain, it leads to higher outcomes, that is, more weight in the hair than the growth pattern in the placebo group. We can see this further by looking at the descriptive statistics. And in particular, we're going to focus on the means. If you look at the means here across the various weeks for the placebo group, there's not a lot of change. 0.17, 0.18, 0.18, 0.19, 0.18. Pretty standard, as you would expect, because they're just receiving a placebo. So you wouldn't expect the hair growth to be any more pronounced than what it normally is. Whereas with the group that's receiving the row gain, the averages are 0.16, 0.19, 0.22, 0.22, 0.23. So I notice that there's some initial growth and then it seems to plateau. And looking at the interaction plot, I can see this even clearer. This is now focusing just on the means, and I notice the row gain group, in which I have a solid line, is increasing to about week number 16 and then seems to plateau and maintain. So whereas the placebo group, there's a little bit of change, but not much, and then it kind of comes back down. In the Rogaine group, I get a big increase, at least relatively speaking, and then it seems to plateau. Now, this should make it evident why we're primarily interested in the interaction and why we're not interested in main effects. Let's think about what the main effects would be. The main effect for treatment and control would mean we average all the weak numbers together in the treatment condition and average all the weak numbers together in the control condition and then compare them. That wouldn't tell us a whole lot, would it? Taking the average across all these weak numbers when you're expecting and primarily interested in what kind of change you have across the weeks. So the main effect here would not be of interest even if there wasn't an interaction, because we'd be averaging across the weeks, and that doesn't mean a whole lot. That the whole idea here is to see what kind of change we get across the weeks. Similarly, if we were to look at the main effect of week, we'd be averaging the Rogaine and placebo conditions. So we would look at week 0 here, everyone averaged together. Week 8, everyone averaged together. Week 16, that makes no sense either, because the women are in two different conditions, placebo and Rogaine. Why would we want to average them together? So what I'm trying to make a point of here is when I said that the interaction is typically in these kind of studies the only thing that's of interest, I'm trying to make the point of why that is the case, because it really wouldn't make sense, regardless of whether there is or isn't interaction, it wouldn't make sense to average across all the levels of one of the variables in order to look at the effects of the other variable. So we're only going to focus on interaction both in this example and in your real research studies in which you're using this kind of design. And this should also make clear when you would want to use this kind of design. It's when you're wanting to see what kind of trends you have and how they differ for different conditions. If I was doing educational interventions, I might want to test students at certain intervals. And if I am looking at 2 or 3 or 4 different interventions, by testing students at those intervals, I can see if one group tends to be gaining more and more and more as time goes on than the other group, or maybe one group gains and then the other one catches up. You can look at all the patterns, and that's really what's of interest to you. Okay, so if we look back at the actual analysis code that I used, there's nothing new to learn over what you could have gained in past videos in this box plot code, because all I'm doing is treating it as 2 factors. Notice here how I'm crossing the 2 factors. I have my response variable weight as a function of treatment by time. So it's just as what you learned when we did 2-factor analysis of variance, and this is indeed a 2-factor analysis of variance. The only difference is one of the factors are between and one of the factors are within, whereas before, when I first taught this, we were looking at 2 between subjects factor, but the code is just the same, and the way we look at the box plots is just the same as when we did it in the 2 between factors analysis of variance. The code that I used for looking at the summary statistics is also the same. So I'm not going to repeat going through that, because I went through that. If you haven't looked at the video for summary statistics for 2-factor analysis of variance, I invite you to do that. In that particular case, we were looking at guinea pigs and method of delivery of vitamin C, and looking at how that method of delivery might have been different for different dosages, and looking to see how it changed the teeth growth of those guinea pigs. But here it's the same sort of thing. So I have a separate placebo condition set of statistics and a separate treatment condition. Again, you're going to have to take some of this with a little bit of a grain of salt here because we've only got 4 women. So when I'm talking about things like first and third quartile, doesn't seem like that's going to be very informative. Down here for the interaction plot, once again, this is very much like we did before, where we had a treatment condition. Here we have a treatment condition and a time condition, and we do by weight. I do have a legend here that is distinguishing between the between subjects factor, whereas before, when we looked at this in the 2 between subjects factor design, this axis, this x-axis down here, where I now have week number, that was a between subjects factor. This is a within, but the setup up here for the plot is just the same. I did put in, instead of different colors of lines, I put in different line types. I used the codes 1 and 2, 1 for treatment to give a solid line, 2 for control or placebo to give a dotted line, but we could have used 2 different colors instead if we had wanted to. All right, so this is what we do for descriptive statistics. We're focusing primarily here on the means and the standard deviations. I noticed the difference in standard deviation at time 0 before we've ever started treatment. It's the standard deviation is about twice as much in one group, a little more than twice as much in the treatment group as the control. I also noticed the standard deviations for the control group stay about the same. The standard deviations for the treatment group vary a little bit from in times 8 and 16, but then are about the same in 24 and 32. Maybe that indicates that it's taking longer to be effective in some women than for other women. And if you look back here, you can see that I have a decrease in times 24 and 32 compared to times 8 and 16 in the variations. So maybe what's happening here is that you get a bump, but not quite as much for everyone, and then it all kind of levels out for everyone. We'd have to look specifically at individual data points to know that for sure, but that's what it's kind of looking like to me here. Okay, so now what we want to do is we want to look at the inferences that we can make, and so I'm going to turn to that in the next video.